Non-toxic, of course, it will be very important because we need to reduce the adverse effects on the human health and the environment. So these are, I believe, the key of the principle for the green nanochemistry, which is ensure that this nanotechnology, it will be sustainable and it will be having the protection of the environment. So the principle here will guide us as researchers, scientists, participants, whatever, to inform that the decisions, the responsible for this nanomaterials, it will be the society and the planet, not also just the researcher. No, we should advise other people, just tell him about this importance of it. Of course, we have a lot of advantages of this green nanochemistry. Like what? Here we have the environmental preservation, which is having the focusing about the sustainable and the eco-friendly practices by reducing the hazard chemicals. Regarding to the resource efficiency, also it will be renewable, as we mentioned before, and it will affect the efficiency of it by having the resource utilization, by having these green nanomaterials. As usual, these type of materials, the main source of it, it will be the natural resources, which is reduce also the ecological footprint with the carbon. Now, regarding to the safety, as we know, during our work, especially in the labs and the factories, whatever that we have, the safety is very important. In our priority, safety is first. So in this kind of non-toxic nanomaterials, it will be more safer for the applications, for the industrials, for the medicine, for the consumer, for the products, for all types of these chain of work. Enhance also this biodegradable material, which is promotes the nanomaterials, which is having the break down this useful life, and it will reduce the nanomaterials in the ecosystem. Sustainable application, of course, when you are using these type of materials, the meaning of that we are focusing about the renewable energy, which is having the sustainable solution for these global challenges that we have it nowadays. Positive also regarding to the public issue, which is having friendly practices of this nanotechnology, which is improving this acceptance of the applications by human and by public. Compliance and the regulations, of course, it will relate it to the more easier issue, especially for researchers, for industrials, because as you know that in the industrials, they are always focusing about the cost and these application, how to have it. So this is, I believe that it will be more easier than the other, especially by dealing with it, by having the waste of it and these parts. Innovation and the collaboration, always we are looking forward for this collaboration among our researchers, friends, colleagues, industrials, how to convince the policymakers in order to have this point of view that you have to be more sustainable nanotechnology solutions in your field, in your issue that related to these parts. Also, when we are looking at it, we have to think about the economy part. Is it having this kind of economic benefits? Of course it have. Why? Because when you are having this novel eco-friendly nanomaterials, it will be having also the commercial applications, which is can create new market opportunities. And this is very, very important part. If we are going to the industry, how can we convince them that go towards like this type of materials? Of course, we have to convince them in this point that when you are achieving this kind of materials, when you are going to the green nanotechnology, you are also having these economic benefits to your field. And I believe that they will be convinced. Also, this is related to the global goals, which is supporting the United Nations Sustainable Development Goals, the SDGs. So as we saw there, the advantages of it is very important regarding to the positive impact on the human health, the environment, and all of these parts. And also it will evolve the rule of shaping more sustainable, responsible future for our field or for nanotechnology. Examples about the application or the real application about the environmental imitation, which is like, for example, the water purification. If you are working in this field of water, we can use these nanomaterials because it will having the efficiency how to remove the heavy metals, the organic pollutants, and I tried this by myself. I prepare something regarding to the olive powder, olive leaf powder, and we try to treat the oil and the waste from the oil, and we success in this. And we published this article, by the way. Nanofiltration also, and nanomembranes, which is treating the wastewater, offering the more energy efficient and cost-effective solution for this water purification. Also for the air pollution control, this nanocrystals or catalysts, nanomaterials, it will be in the filters, which is like the nitrogen oxide or all of these kind of harmful substance, it can be tracked to it. For the soil remediation, which is having the, like the ZN, this is nanoparticles, which is have the less harmful forms of it, which is going to offering more precise and target soil cleanup. For the oil spill cleanup, as my example before, regarding how to recover the oil spirals, it will also having the more efficiency, like the, if you compare it with the traditional method that you are using. Groundwater also, protection, which is related to the treat of this contaminated groundwater, removing the pollutants from it, and how to develop the detection of these contaminants of it. Here, the enhancement of this phytoremediation, as you can see here in this photo, I don't know, it's not clear. So this is, it will affect on it how in the plants, how to remove the pollutants from it regarding to the environment. By having this increasing of the efficiency of this phytoremediation efforts by using this substance. Radioactive waste treatment also, it will be having the nanoclays, which is having the substance to clean up and the having the contaminants of this radioactive wastes. Here, I believe it will be something very, very important. I just put for you two examples here regarding to the antibacterial coating. We are always focusing about the corrosion, the coating, what we are having, what we can use, how to be, and this is my specific field. This is here. Here I put for you just two examples here regarding to the two metals here. This is this one, it will not be coated. Look at it. What will be happen to that? And the other one, it will be nano coating by this kind of nanomaterials, which it will be antimicrobial properties of it, which is having, we can also use it in the hospital equipment, the water treatment systems, all of these kind of, and also here we have the different or the other example about it to prevent the growth and the spread of this harmful bacteria. So this is very, very important part that we can use it in this kind of system, especially for the hospital equipment. So as we can see here that this kind of application, it will provide the effective solution for the environment, promoting the healthier ecosystem that we are living in it. So this is, if we follow these kind of application, of course, we are going to achieve the sustainable remediation outcomes from it. Energy storage and the conversion, as I believe that it's very important part here that, excuse me, here is raising his hand, Mr. Muhammad. I believe that the question, inshallah, it will be at the end of the lecture. So this is, it will offering the solution like what? Here, first of all, we are talking about the lithium-ion batteries. Let us go to the real examples about these issues. Now, as we can see, especially in Europe, that you are going forward, like the 2030 policy, that all of the cars that you are using there, it will be regarding to this type of electrical car, which are, as we know, like the Tesla car, they are using the lithium-ion batteries. In this kind of issue, we can also improve them by having these nano components regarding to the electrolytes, which is, it will going to improve what? The performance of this capacity of these batteries. When we are improving this performance, the meaning of that, we will have the long time of working of it by having this service area of the electrodes, facilitating the diffusing and how we increase the battery efficiency of it. Of course, we will compare with the other type later on, inshallah, regarding to the solid state battery. Capacitor, the supercapacitor also, it will having the carbon-based materials like the carbon nanotubes. Also, it will be something very important to use. This is, Now, I believe that all of you read about this issue, and this is very, very important part, that now they achieve this solid state batteries. Here, of course, they're having the kind of the application of the nanochemistry, which is having the issue about the solid state electrolytes, which is having the ionic conductivity inside it, which is increase safety and the energy density of these batteries. As you can see, can you imagine that this is a battery for the car? This is the real example I bought for you that now the Toyota company, this is a Japanese company, they are now having the plan at the 2027, they are going to apply this type of batteries for the cars. Can you imagine what are the nanoscale that you are using there? This is, it will enhancing the stability of it, and it will having what? And instead of having the charging of the car for 4 or to 5 hours, here it will 10 minutes, it will be enough to charge the car. And instead of having the car just moving for example, 400 kilometers, it will move for more than 1,000 kilometers. Can you imagine the difference? I believe, my friend, that we should go towards this kind of research, because I put for you here the paper here that we have it, and I put it at the end of my lecture, that this is a solid state battery now markets. Now they are spending for this kind of market and research something around $3.4 billion. So this is a huge or massive number that I really understand or read about the kind of research. So this is now your opportunity to do the research or read, or at least we can do what? We can collaborate to do one of the review article about this type of issues, which is I believe that it will be now the new trend, this one. The solar cell also, it will be something important regarding to the solar power, which is having the enhance of the light absorption and also the change of the carrier separation of it. Thermoelectrical material, I believe that I put for you here one of the example of it, which is having the nanomaterials, which is enhance the electrical conductivity and reduce the thermal conductivity, leading the higher thermoelectrical efficiency. And you are using, instead of that kind of service, you are decrease the service at least 10 times. And regarding to the efficiency, you will have more efficiency, maybe more than 50 times.